So now we're going to apply what we know about counting atoms to balancing equations, the steps to balancing equations. The first thing that we need to know is the law of conservation of mass. And basically it says that you can't create or destroy mass. Whatever you start off with on the reactant side, so remember this side right here is your reactants, and this side over here is your products. Okay, and whatever you start in the reactant side, you have to finish in the product side. So if I have, let's say, 2 hydrogens in my reactant side, I have to eventually have 2 hydrogens in my product side. Now, it might look a little different. I might have new compounds, but I have to end up with the same number of atoms. So you want to have the same number of atoms on both sides. They can be a little bit rearranged, but you want to make sure that you have, the same amount of hydrogens that you started with at the end, because you can't lose hydrogens. You can't destroy matter. We're going to do what's called balancing an equation. So the first thing I want you to do is I want you to draw a perpendicular line right where you see the arrow. So you know that the arrow means yields or produces, right? So put your line down. Then I want you to start listing what elements are given. So right now you have H's and O's given on both sides. And I'm only going to write H and O once, but I'm going to write the total numbers of those H's and O's on both sides of the line. I'll show you what I mean. On the reactant side, we have 2 atoms of hydrogen, and we also have 2 atoms of oxygen. On our product side, we have a 2 for our hydrogen again, but we only have 1 for our oxygen. So this is not a balanced equation. We're going to balance it. So what I want to do first, obviously our hydrogens are balanced, but our oxygens are not. So what you want to do, this is where you're going to write coefficients in front of your molecules. So we're going to put a big 2 in front of our H2O. I didn't give myself a whole lot of space, but we're going to put a big 2 in front of the H2O. What this does is it changes our numbers. So now I have 4 hydrogens. So I'm going to go ahead and cross the original 2 off. I'm going to put a 4 down now because I have 4 total hydrogens. I now have a different number of oxygens, so I'm going to cross this number off, and I'm going to put a 2 because now I'm going to distribute that coefficient throughout the molecule. Remember how we did this before? Distribute it throughout the molecule. I have 4 hydrogens and 2 oxygens. Now look at my total chart. H's are 2 and 4, O's are 2 and 2. So my H's are off. I got to look at my reactant side now. Let's make hydrogen a total of 4. How do you do that? Add a coefficient in front. Now when you distribute it, 2 times the 2 hydrogens that are already there gives me a total of 4. So we're going to cross off our original number of 2, and we're going to put a 4 in place. Okay? Now, the plus sign right here, the plus sign does not get affected. This does not affect the oxygen gas. So, let me erase that. The 2 only affects the hydrogen. All right, so I'm not going to change my numbers here. I'm going to leave it as 2 because the plus sign is separating it from that coefficient in front of the H2. So if that's the case, I can look at what I'm given. H is 4, H is 4, O is 2, O is 2. This is a balanced equation. My final answer would be 2H2 plus O2 yields 2H2O. That would be my final answer. So let's do a couple more practice because we're going to start balancing equations in class. So here's some other practice problems. My first one is K, which is in the solid form by itself, plus water. So you're looking at this purple chemical equation right here. I'll highlight it. K plus H2 yields KOH plus H2. And I hope you recognize when I said KOH, I hope you recognize that the OH is a polyatomic. And it has a -1 charge, and if this has a -1 charge and this has a +1 charge, I can write the formula KOH, and I don't need any subscripts. So for this first problem that I'm highlighting right now, you want to go ahead and take that line again, put it perpendicular to the arrow. Now I want you to start writing down all the elements that are involved, and they're going to be on both sides of the equation, otherwise you totally wrote it wrong. So you have K, H, and O on both sides of your equation. K, H, and O on the reactant side, K, H, and O on the product side. Now it's a little bit rearranged, but that's okay because that's what a chemical reaction is. It's a rearrangement of atoms. So let's go ahead and start counting what we're given. All right, for K we have 1, so we're going to put a 1 here. On the reactant side we have 2 hydrogens, so we're going to go ahead and put a 2 there. And we have 1 oxygen. So don't even worry about the L and the S in parentheses. I'm not going to write that all the time. I'm hardly ever going to write that. That's just telling you the state of the matter. But we have 1 K, 2 H's, and 1 O. On the product side, we have 1 K, we have 1 O, and here's the trick. We have an H in the KOH, and we have 2 H's in the hydrogen gas. You want to add those together. So you have a total of 3. Oops, I made a mistake. The 1 was for the oxygen. Sorry about that. You have a total of 3 hydrogens, 1 in the KOH and 2 in the H2 gas. So this is your initial numbers that you're working with. Now you see the K's are balanced, the O's are balanced, but the H's are not. So let's try to find a way to make these balanced. I'm going to tell you right now, even numbers are your friends when you balance equations. So let's look at the product side. We can start with the product side if we want to. Notice that you have an H by itself, and then you have an H with the 2. The H by itself is an odd number, and you know it will work better if we don't have odd numbers. So let's go ahead and try to make the H's a total of 4 on the product side. So what do we need to do? We need to add coefficients. Let's go ahead and put a coefficient of 2 in front of the KOH. That, if we distribute it, it will now give me 2 H's plus another 2 H's, which will give me a total of 4. So let's go ahead and change our number of H's. So cross that out, put a 4. Now you have 4 hydrogens. But it changed our potassium count. So go ahead, cross off your potassium, change it to 2 now because you're going to have 2 potassiums. All right. It's also changed our oxygen count. So go ahead and cross off your original oxygen count and put a 2 next to it. So these are our new numbers, 2 K's, 2 O's, 2 plus the additional 2 with the H2 gas to give you 4 hydrogens. Now let's look on the reactant side. My potassiums are off. That's pretty easy to fix by just putting a 2 in front. So why don't we go ahead and do that? Put a big coefficient of 2 in front of the K. That'll change your numbers for your K to 2. So go ahead and change it in your chart to 2. Make sure you cross off the initial 1. All right, but that 2 does not affect the H2O. It only affects the K because of the plus sign. So let's see. We have 2 hydrogens on the reactant side, 4 hydrogens on the product side. Let's go ahead and try to make the hydrogens 4. Go ahead and put a 2 coefficient in front of the H2O. That'll change your water or your H's to 4. So go ahead and change that to 4. But it also affects your oxygens. So change your oxygens, cross that number off, change it to 2, and you're good. Now let's look at the whole thing. 2 K's, 2 K's, 4 H's, 4 H's, 2 O's, 2 O's. You're balanced. Just to make sure, go through the original equation and double check. How you do that is 2 K's, 2 K's, 4 H's, 2 plus 2 would be 4 H's, 2 O's, 2 O's. You're balanced. So your final answer is the top equation in the purple and red. Include the coefficients, include it all together. Let's go ahead and do the next one. The next one, NH4 plus O2 yields N2 plus H2O. Let's go ahead and draw our bar. Perpendicular bar, remember, at the arrow. And let's go ahead and write all the elements that are given, N, H, and O. On both sides, you have N, H, and O. So we're going to start by writing the total numbers on our reactant side. Our nitrogen is 1, so let's go ahead and put a 1 next to the N. Our hydrogens are 4, so put a 4. And our O's are 2, so go ahead and put a 2. On our product side, we have 2 N's. We have 2 H's. And we have 1 O. So this is, you learned how to count atoms in a chemical formula, so now we're applying it. Let's look at our chart. We have 1 N to 2 N's, 4 H's to 2 H's, and 2 O's to 1 O. Let's go ahead and just start with the N's. It's easy enough. We're working with all even numbers, which is really key, except for the ones, but those are easy to change. It's really key to have even numbers when you're balancing equations. So if in doubt, try to get it to an even number by using a coefficient. So let's change our N's to 2. Go ahead and cross off the 1. Let's add a coefficient of 2 in front of the NH4. So 2 times the N will give me a total of 2 nitrogens. So change your chart, change your nitrogens to 2. But it's also changed our hydrogens to 8. So go ahead, take your hydrogen, cross off the 4, put an 8 next to that 4 because now you have a total of 8. Did this red 2 affect my O2 in my reactant side? No, because the plus sign's there, so this is not going to affect that because of the plus sign. So just leave your O2 alone. Okay, so I still have 2 O's. Now, on my product side, my N's are balanced, my O's are not balanced, my H's are not balanced. Let's do easy. Let's look at our O's. We can easily make our O's 2. Let's go ahead and put a 2 in front of H2O. Put a big coefficient of 2 in front of our H2O. What will that do? That'll change our H's to 4 and our O's to 2. But didn't we want 8 H's? 2 is probably not going to be the right answer. We're probably going to have to erase it. So before we go any further, let's just get rid of that 2. And let's go ahead and put a 4. Because we know we need 8 H's in the final answer. So let's just go ahead and round it up to, let's go all the way up to 4 for our coefficient. So we're going to look at our chart, cancel out our H. We're going to put 8 down because of 4 times the 2 will give us a total of 8. And it also tells us 4 times 1 will give us 4 oxygens. So let's go ahead and change our chart. All right, so now we have 8 hydrogens and 4 oxygens, but our reactant side is wrong now. Very easy to do. Our O2 is separated from everything else. How can we get 4? Just put a 2 in front of the O2. That'll give us a total of 4. So go ahead and change your chart. Get rid of that 2. Now we have a total of 4. And let's look at our whole chart. We got 2 N's, 2 N's, 8 H's, 8 H's, 4 O's, 4 O's. We're balanced. Just to double check out your equation. 2 times 1 would give me 2 N's. Here's my 2 N's. 2 times 4 gives me 8 H's, and you can see 4 times 2 gives me 8 H's. 2 times 2 gives me 4 O's, and we have 4 O's right there. Here are some practice problems I'd like you to put in your notebook. We have 6 practice problems. The blanks are for coefficients. You don't have to fill out every blank. If you don't fill it out, that indicates a 1. We don't write 1s for coefficients. So some of these blanks are not going to be filled in. Some of these problems might be already balanced, and you don't have to do anything. Thanks a lot for your attention, and I hope you enjoy balancing equations.